Hi everyone, so today we're going to be solving the chapter 9 periodic quizzes for chapter 9. So we have 4 quizzes. They're really easy, not that hard. And yeah, let's start. So now this is the 9.1 quiz and it's asking us to distinguish between these two graphs. So graph A shows the variation of the concentration of the reactants over time, while graph B shows the variation of the concentration of the products over time. We know no graph is about the reactants because reactants are being used up. When they're being used up, they're decreasing their concentration. So they're getting less because they're turning into products. Because we know reactants turn into products. So if more reactants are turning into products, this is going to decrease and this is going to increase. So that's why they're like opposite. They're flipped. They're the inverse of each other. So whenever reactants is decreasing, products is increasing. So that's what the question is telling you, that the concentration of reactants over time decreases while the variation of the products increases. So whenever you have two graphs and your only options are reactants and products, one going down is reactants, one going up is products. Okay, so next question. Our next question is showing us also another two graphs. So consider the reaction between the magnesium ribbon with excess dilute hydrochloric acid, and they're telling you that hydrogen is produced. And be careful, always when you see these types of questions, know which one is your limiting and which one is your excess. So hydrochloric acid is your excess and the magnesium is your limiting reagent. Why do we need to take care of what it is? It's because we know that the limiting reagent affects the graph. Whenever you change the limiting reagent, you're going to change where the graph ends. So the rate of the reaction is increased from when we're going from A to B. If you're going from lower point to a higher point, if you're shifting up, but they're ending at the same point, the rate of your reaction has immediately increased. That makes sense. Now let's see part B. Which of the following perturbations could have been done going from experiment to A to B? So they're telling you what could have been changed from A to B to have increased the rate. So let's see. Using less magnesium ribbon? No, because decreasing the concentration of solids or decreasing the amount of solids used isn't increasing any rate. Using magnesium powder? Yes, because we know that one of the only things that increases for solids is increasing surface area. For solids, the things that affect it are temperature, are catalysts, and surface area. Catalyst, that's supposed to be a catalyst, and surface area. Okay, actually, guys, I'm gonna go get something to balance on because my handwriting isn't amazing. Later, though, adding a catalyst, yes, because like we just said, it's one of the only things that increases the rate in solids, and catalysts will increase every type of rate: solid, liquid, gas, and aqueous. It and temperature affects everything, not only solids. Warming, yes, which means increasing temperature, which yes does increase the rate. Decreasing surface area, definitely not. You have to increase the surface area for it to have an effect. And let's see if there's any more parts of this question. No, there is not. Okay, so this question is pretty simple. Now, when zinc is reacted with excess dilute hydrochloric acid at room temperature, the volume of hydrogen produced is noted every 10 seconds. So know that zinc is your limiting reagent and your excess is hydrochloric acid. Whenever there's a change to hydrochloric acid, it doesn't matter, but when there's a change to zinc, it does. So let's read. A leakage of gas has occurred during the experiment. The only logical thing is E, because it's not supposed to end here in no case. this is very little amount, so it means that something external must have happened. Only half the zinc is used. Now we know that whenever your whenever your limiting reagent is affected or different, you have less like you have different end of slope. So if this C was your original graph, if you increase the amount of your limiting, it will go up to A, and if you decreased your amount of limiting, it's gonna go down to D. The only way it can go up to B is if you change anything other than the limiting. So here they told you in part B that you decreased the amount of zinc, which is your limiting, so it has to end lower than the original, so it's gonna go down to D. Slightly warmer excess acid, we told you that if you change anything other than the limiting, you're only changing the rate. You're not changing anything about the ending of the graph. It's going to remain constant, so you choose B in this case. And greater mass of zinc, like we said, if you increase anything in the excess, you're going to have a higher end of slope. So A is your answer because you increased an excess. Now let's see what part B is asking us. So part B is telling us, just let me make sure, yeah. So part B is asking us what's the final volume obtained in experiment C. So you just have to go up to experiment C, which is your original graph, and go to where it slopes. And you draw a line. It's supposed to be a straight line. And you're gonna see where it ends. It hits 30. So that's how much volume was produced. Like, see? 30. Okay, now this quiz has only one question. It's really easy. It's a definition, so you have to memorize it. Chemical kinetics is the study of reaction rates. It's like just reaction rates. Because it's a definition, you have to memorize it. If you don't memorize it, there's no other way to know that it's in the exam. And that's 9.2 done. Now on to 9.3, the longest, probably, possibly, arguably, the hardest quiz. But like I said, I need to quickly move where I'm sitting because I don't like the mouse here. Okay, yeah, now I changed where I'm sitting, so let's get back to chapter 9.4. So, oops, dropped something. Anyways, first question, it's telling us that in which of the following factors increase chemical reaction between a solid and an aqueous? I have my chemistry copybook here. My teacher gave us this graph. I'm gonna draw it for you guys at the end of the video. It's about everything that affects the rates between solid, liquids, and gases. Let me just pull it out really quick. And yeah, I have it. So, know that in aqueous, the factors affecting aqueous solutions are concentration. The symbol symbolizes concentration, by the way. Temperature, catalyst, oh, I forgot that. Catalyst, and yeah, that's it. That's the things that affect the rates in aqueous solutions. And now for solids, the things that affect the rate are surface area, temperature, and again, catalyst. I'm not gonna sit down and write it. And in gases, if I'm not wrong, but wait, I think I pulled the wrong graph from my copybook, so let me find the right one. Okay, yeah, I found it. Turns out they're the same. Anyways, in gases, pressure is one factor that affects. And Another is temperature, of course, catalysts, and concentration. These are your factors that affect. So let's see for solid and aqueous solutions. Increasing concentration, yes. Increasing temperature affects everything. Increasing volume, no. Because either way, if you're increasing the volume, it's gonna take longer for you to reach your endpoint. So it's not really helpful. And it's gonna decrease the pressure. So either way, it's definitely not. Increasing surface area of solid reactants, yes. And adding a catalyst, yes. Now let's go on to question 2. Okay, so which of the following interventions could change the number of collisions per second? So whenever you see, also decreasing the concentration, no, we need to increase concentration, so definitely not. Increasing volume, we said whenever you see volume, we don't touch it, we don't look at it. Volume and pressure, don't look at it in this quiz or any of these cases. Increasing the area of contact, yes, which means like you're increasing the number of collisions, or like you're increasing more concentration or particles, so more will bump together and whatever. Decreasing temperature, definitely not. You need to increase the temperature. Increasing concentration, yes, definitely. So this quiz is pretty much just memorize what affects collisions. Okay, why is this entire quiz wrong? The thing, okay, so fine. So which of the following is represented in the above diagram? So when you have particles that are stationary under a point and they start moving, like they start bumping around corners and everything, it's increasing temperature. Because if you added a catalyst, okay, it would increase, but it wouldn't be like bumping around directly. In gases, catalysts don't, like you need to see a catalyst. You can't see a catalyst here because catalysts aren't used up. Decreasing surface area, definitely not. This is a not. And decreasing concentration, no, you need to increase concentration. So the only thing that makes sense, what you did is you increase the temperatures, because see, they're now bumping around. Now, next question. Okay. Which of the following affects the rate of chemical reactions? Okay, so for chemical, we said concentration, definitely. Surface area, yes, which means more particles. Color, what does that really have to do with anything? It has no effect on anything. Temperature, yes. Concentration of product, no, it has to be concentration of reactant, not product. If it says reactant, yes. But since it's product, no. See, it has to be of reactants. So that's it for this question. On to the next. Oops, sorry, no. Okay, so this question. This question is in your CQDs, so it shouldn't be that hard, and it's really easy. So what's happening here is you have this experiment that's happening between thiosulfate and hydrochloric acid. So they're telling you that this is your reaction, and you have this person looking down at a cross on the paper, and whenever you add the reactants together and everything, it will turn cloudy, which means it's gonna cover up on the X. You can't see anything. It becomes opaque. It's not transparent anymore. And when it has 100 centimeters, the beaker contains 50 centimeter cubed of molar of sodium thiosulfate was placed on a black cross. You had 5 centimeter cubed, 2 hydrochloric acid, and a clock was started. The experiment was carried out at 20 degrees Celsius. So I'm just going to write down all our factors again that were given here, so I don't lose them when I scroll down. So you have 100 centimeter cubed, and you have 50 moles, centimeter molar. I've heard of that before. Okay, my charge is gonna go out. Okay, yeah. So, okay, 50 centimeter molar. You have, okay, I don't think the M here, I think it's a typo. Because what is, المهم. You have, yeah. So now you have these factors, and it was carried out at 20 degrees Celsius. I'm not gonna continue with these. It's just telling you this was used with these factors in mind. So now, let's see. So why is it necessary to keep the total volume the same in all experiments? If you see here, you kept the total volume the same. You didn't change it at all. You changed the total volume. You didn't change the total volume nor the volume of the acid. And this is used for fair comparison. Because when you're doing an experiment, you always have to keep at least one or two factors constant. If you keep changing these factors, you're gonna get wrong results. So now let's read 2. If the reaction is repeated at 40 degrees Celsius, so let's see how much was it here done. It was carried out at 20. So now if you're doubling it, the rate of the reaction is definitely going to increase because more temperature, more reaction. Because the particles are going to move faster, because when you increase the temperature, you're increasing the speed of the particles and they'll have more frequent effective collisions. This word is really important. When you're writing in your written, you have to have effective collisions. They will increase. Now, when the cross disappears, it's because the sulfur precipitate forms. Because when these two together they act, they're gonna make a sulfur precipitate. For this part, you actually have to just memorize what it makes because they're an experiment, and you can't really like guess what it is. It doesn't tell you in the question, I think. So this one, just memorize it, that a sulfur precipitate forms. And now if this experiment was repeated using a 250 centimeter cube beaker, how much beaker was it used? It was used using a 25 centimeter cube beaker. If it was used using a 25 centimeter beaker, the time would be longer. Why? If we're using a beaker that's this size or a beaker that's this size, wouldn't the particles here bump into the walls more frequently because they're closer to each other? But whereas here, if this particle wanted to reach this wall, it's going to take way longer than if this particle wanted to reach this wall. So this here is less, and considering we have the same number of particles, this is going to take you way longer time. Like way longer. That one is definitely faster. So the less volume you have, the faster it's gonna be. The rate doesn't change because you're gonna have the same rate. It's just the time for the rate will change. It's just gonna take a bit longer to finish, but they're both gonna finish. So next question. Now here you have dilute hydrochloric acid, and it was added to excess calcium carbonate. We know that hydrochloric acid is our limiting reagent, and it was done at temperature 25, and the gas was produced. They didn't tell us what was this gas. Now they drew this all on a graph, and they're asking us the question. So what's the role of the cotton wool? Know that if you have a balance, when you have a balance, what you're trying to do is find out the rate by seeing how fast these diffuse out of the beaker. Because when you increase temperature, when you're having a reaction, the gases are going to be formed, and when the gas is produced, you're going to increase, like it's going to leave, because a gas is a gas. And the cotton wool here is used so the acids, because you have acids here. When acids react, they like making a mess, they'll splash everywhere. So the cotton is, one, to prevent any acids from splashing, and two, so to let the gas escape. Because if you put a wooden cork or like a cover of plastic, it won't have holes where the gas could escape from. So let's go back. It allows the gas to escape and prevents the splashing of the acid. See, it measures the temperature. No, how is cotton gonna measure temperature? Speeds up? No, it's not. It homogenizes the mixture. We didn't even take anything like this, so definitely not. Now the release of Here's the part where you have to memorize. In this experiment, carbon dioxide is released. They don't tell you. You just need to know. How? Don't ask. This is memorization. It's really just memorization. There's no way of knowing. And it causes the mass to decrease because when it's escaping, it's going to decrease. Now, this experiment was done at 25 degrees Celsius. If you doubled it, knowing that the black is your original equation and red is your new equation, what's going to be different? So we said that if you're not changing anything in the limiting reagent, they're going to end at the same point. Here you could see that they're ending at different points. And here also you could see that they're ending at different points. So without even thinking, this is your correct graph because they both end at the same point. And let's say this graph ended at the same point. Let's say they both ended at the same point in this graph. And knowing our red is the new one, it's increasing because the temperature was doubled. So either way, the red should be above the black. So that's this question. Like I said, really easy. Okay, so 3 different experiments were used. You had excess calcium carbonate and hydrochloric acid, and now it's asking you how does each factor or condition affect the rate. Lower temperature, it's gonna be B, because we said as long as you're not changing anything with limiting reagent, you're gonna end at the same point, which is here, but you're gonna be lower or slower rate. So this one's B. Lower concentration of hydrochloric acid, which is our limiting, because this is the excess, this is our limiting reagent, LR. Always keep a mental note of your limiting reagent. So lower concentration, you're gonna be at C because you're decreasing something to do with the limiting. Using lumps instead of powdered calcium carbonate is gonna be B because powder has more surface area. Powder is like this. Powder has a lot. Powder has 365 like surface around it. You get what I mean? But lumps, they're blocks. This powder has more surface area than this. So if you cut this up and smashed it into powder, they'll have the same. Addition of catalyst speeds up the reaction rate, so you'll be at A. This question comes every per AMS, so it's probably going to come in the periodic tomorrow. So based on the collision theory, a decrease in the temperature will decrease the rate of the reaction because the number of effective collisions decrease. This is very obvious because decreased temperature will cause everything to decrease. So whenever it tells you decreased temperature, concentration, anything like that, everything's gonna decrease. Okay, so for this question, it was a bit confusing for some people, but I figured it out and it's not that hard to solve, actually. So let's see. I'm gonna keep my pen here. So we need to look at our equations and, oh, sorry, what's that? We need to look at our equations, all the equations given, this, and this. And we need to read the question really well. Quantitative studies have found that CO has no effect on the rate, but increasing NO2 increases the rate. So this has an effect. For this question, you read, personally, when they ask you for slowest step first, it means which one's the determining step, which one's the rate determining step. The slowest step is always the one that determines your rate. So if here you have NO2 and NO2, and we said that NO2 it affects your rate. Here you have NO3, which nothing about it was mentioned about it changing rates, and CO has no effect. So if CO and NO3 have no effect on your rate, and NO2 both have effects on your rate, these are the rate determining steps. The thing that has the effect on your rate determines your step, and we know that the rate determining step is the slowest step. Like, because it's the rate determining step, it's slowest. Not because it's slowest, it's the rate determining. Now, if you know it's slowest and they told you it's the slowest, it's the rate determining step. But if they're asking you which one is the slowest, find out which one is the rate determining step. Now, back to question 10. Here they gave you a graph and they told you at point x 7.5 seconds is not on the graph. Like here, it's here. This isn't because of the experiment or anything. This is probably human error. A person reading it got the wrong reading. And it's normal. Like, no, every human makes mistakes. You can't perfectly, we don't have perfect vision that we can see. So this is probably a human mistake because of the wrong reading of the volume, human error. That's it. So what volume is collected after 10 seconds? So you go to 10 seconds, you go up, 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 up. And my cursor is very lopsided. You go then left when you reach, and it's at 15. That's how we get this answer. So just look at your graph. Now, when you have 19 centimeter cubes, it's at which second? So this is your 19. We go straight, 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 and we go down. And this is between the line I'm on is between the 10 and the 20. It's supposed to end here, but excuse my lines. So this is probably 15 seconds, because if you count the spaces between each one and the other, you're gonna find out it's 10 spaces, and this being the middle is 15. So let's go on to the next part. What causes the reaction to stop? The only thing, the catalyst is totally consumed. No, catalysts do not get consumed. This is a big no. Catalysts don't get consumed. If they get used up, but then they're reformed, so they'll come back. They're never used up fully. So the fact is wrong. So of course it's wrong. Surface area of reactants decreases. No, how will it decrease? And it's not gonna decrease because there's no surface area either way. Temperature drops? No. This doesn't cause it to stop. The reactants are totally consumed, yes. Because I don't know if you remember in this quiz, we said that when you have reactants and you have products, reactants are getting less while products are getting more. So when you have no more reactants and they've all turned to products, that's it. Your reaction is done. Now on to question 11. Okay, let's see. Student added 12 grams of powdered CaCO3 to 200 centimeter cubed of 1 molar acetic acid solution, which is the excess, at 80 degrees Celsius, and CO2 gas was produced and collected in a syringe. The volume of the gas was measured at regular time intervals, and the results obtained are given in graph B. This is your original graph, the rest are the new ones. So if you used 400 centimeter cubed of 2 molar ethnic acid. So if you doubled centimeter cubed and you use double the concentration, your rate is gonna double. Or well, not double, but it's gonna increase. See, but it both ends at the same point. If 15 grams of powdered CaCO3 were used, we know that 12 grams of CaCO3 was used, and CaCO3 is your limiting, because we know that the acetic acid was the excess. So if you increase the amount of CaCO3 you're using, you're increasing the rate, and it's going to end at a different point than the rest. So this is definitely D. The acid was cooled, then it's A, because we know that decreasing the temperature will decrease the rate. This is the lowest rate, so we choose it. And okay, that's it. There is only 3 parts to this question, so let's go on to the next one. Now, this question, it's not that hard, but let's see. The student was to study the speed of the reaction between zinc and hydrochloric acid. Zinc is your excess, hydrochloric acid is your limiting reagent. And it's reacted with 25 centimeter cubed of dilute hydrochloric acid, and it was carried out at 25 degrees Celsius. And it measures every 6 minutes. So at 2, how many minutes does the result appear to be inaccurate here? Because this has nothing to do with your graph. So at 2 minutes, you have to look where it is at 2 minutes. So it's obviously wrong. It should be up here. That's what the graph says. Now let's go down. During the first 6 minutes, the speed of the reaction decreases. Of course it decreases, because like we said, once your reactants are starting to get used up and your products are decreasing, that's it. It's gonna slow down, of course, because we have less reactants. They're turning all into products, so it's gonna decrease their speed. As time passes, the initial concentration of hydrochloric acid will decrease and the frequency will decrease. We said hydrochloric acid is going to decrease because their reactants are getting used up, and if the concentration decreases, so does the frequency of collisions. Now this was done at 25 degrees Celsius. Now they're asking you to show them which graph is at 50 degrees Celsius. So let's look at our graphs and we're gonna see. This, knowing that the black is your original, red is your new one. So if this is your original and your increasing temperature, rate's gonna increase, and we know that you didn't touch the limiting reagent, so your graph isn't gonna end at a different point, and it's definitely not gonna decrease if you're increasing temperature. Now let's finish this quiz and then on to the next quiz. It only has 5 questions, so we should be good. The following apparatus is used to prepare oxygen, and a tube of 1 gram of powdered magnesium oxide was added to hydrogen peroxide solution. So the tube of magnesium oxide is suspended in the flask. Why is it in a tube? Because we want to measure an experiment. So if you just leave it in, you're not going to be able to control your timer and when to start. And you can't have it put in as, you can't pour it in, because we know that acids, reactant, are very violent. If you leave it out normally, like if you have this lying around while you're pouring it in, the acid's most likely going to splash and burn you. So that's why we put it in a small tube like this that's facing upwards, that when you leave the string, it's gonna fall down. And since there's a stopper here, first of all, you know that your reaction has started because you release the string. When you release the string, you start your timer. And it's there because the stopper is not gonna let you get burnt when it splashes. So that's why you're preventing the reaction to start by having it suspended in a flask. The reaction starts when you release the cotton string. We already said that. Magnesium oxide acts as a catalyst. So we know it's a catalyst because we're doing the rate, and because also it's one of the experiments you have to memorize. Using 1 gram lumps, and it will decrease, because here we said we're using powdered magnesium. So using lumps is going to decrease your reaction because we said the powder has more surface area. See? Because lumps have smaller surface area. But the reaction will stop when hydrogen peroxide is completely decomposed. So we literally said that when all your reactants are used up and they all turned into carbon dioxide, they tell us, when they all turned into oxygen, that's when you know it's all used up, because oxygen is a gas. When it's all decomposed, you can't see the gas. It's just going to be measured in the gas syringe here. So let's go on to the last question of this quiz. When there is a danger of explosion when a large amount of dry powdered combustible material is produced, because powder, large surface area. And if it's an explosive powder and it's dry, it means it's gonna, just know that when you have a powder that's explosive and it's drier, it's worse. It's gonna have more explosion, or it's gonna explode more forcefully, more violently, because its powder is worse than lumps because it has a larger surface area. So when the concentration increases, frequency of collisions increase, and this leads to increase of the reaction rate. This is really obvious. So I'm gonna go on to our final quiz. Now let's realize the properties of a catalyst. It provides a new reaction path, yes. With the same activation energy, no. It's supposed to be here, lower activation energy. This is supposed to be lower, not same. Okay, my arrow is terrible. This is supposed to be lower, not same. It provides a higher energy barrier, no. It doesn't. I think it provides a lower energy barrier. It has the same effect on the forward and the reverse reaction, yes. Because a catalyst isn't used up. It doesn't matter. It's just there to change the speed. And if it changes the speed by a certain time, it doesn't even know what speed is it changing. The catalyst is just increasing speed. It doesn't know if it's increasing for the reverse or for the forward. So it's not gonna have a different effect. It's the same effect. It speeds up a chemical reaction. Yes, of course, that's literally the main job of a catalyst. It's consumed, definitely no. Catalyst is never, ever, ever consumed. Literally, one of the properties of a catalyst is it's not consumed. So you can't say it's consumed. It's definitely wrong. Next question. There's only 5 questions here. Okay, so let's go on to part A. We now need to name. So potential energy of reactants are here, A, and potential energy of products are C. Activated complex is your highest point. You look at your highest point, that's the activated complex. And the activation energy is of forward is where your reactants, how much energy they need to reach the activated complex. They didn't draw your backward here, but I'm gonna draw it for you in case it comes in the exam. This is your backward reaction, but you don't need it in this question. In case they ask you in the exam, any arrow coming from the activated complex towards the level of the product, this is your activated complex. Enthalpy change, which is just the difference of heat between the product and the reactants. So reactants and products, it's X. Now let's see. And when you add a suitable catalyst, the value of X remains constant. A catalyst won't affect the heat of products and reactants, or I mean reactants and products. It's not going to affect the heat, but it will provide you a lower activation energy. So instead of this being way up here, when you add a catalyst, this is what it's going to be. This is your activation energy. And whenever you have a lower activation energy, you need less power to reach your activated complex, which is good, which is faster. That's what a catalyst will do. And the value of y, yeah, so this is going to decrease. And this reaction is exothermic because look, we already said this, I mentioned it a million times. When you have your reactants up higher than your products, it's exothermic. And if you draw a slope between the two and it's going down, it's exo. If your slope is going up like this, it's going to be endo. Now, question 3. The substance that speeds up the reaction rate without being consumed is called a catalyst. We know this already, and yeah. Now, I didn't draw anything. Why am I erasing? Now, this question. We said catalysts are gonna decrease your activated complex. It's not gonna increase it, of course. So as long as you have the lower, it's always with the catalyst, and the higher is without the catalyst. And now, okay, so this question I didn't know how to solve it, but now I do. So this question, it's endothermic reaction because look, sloping up. The activation of this energy, like we said, the forward reaction. Wait, so let me erase this. The forward is from this point, which is around 150, all the way to your highest point, which is at 700. So to get this one, you need to do 700 minus 150. You're gonna get 550. Now the activation energy for backward reaction is, let's do it again. We said highest point till it reaches this point here. So it's between 700 and 400, which is 300. I don't know why I'm writing this down, but sure. Minus 400 equals 300. And the forward delta H for this reaction, we said that, what's it called? Delta H is the difference between, I'm gonna draw 2 red lines showing us it's R between here and here. And anything going up is forward, anything going down is backward. So let's see. They're gonna be the same value, except one's gonna be positive, the other is gonna be negative. So going from 150 to 400, you're increasing 250 kilojoules. And going from 400 to 150, you're decreasing 250 kilojoules. So that's it for chapter 9. It's not that hard in the exam. And the AMSs were pretty easy, so that's a bit motivating in the exam, that the exam shouldn't be that hard. For chapter 1, I will try to post the video for it out by today, but because chapter 1 isn't fully with us, it's only till 1.6. I'm gonna have to go over the quiz and ask my teacher what questions are with us, which questions are not. So I can only give you the questions that are actually needed and with us, and how to solve them. So you should find chapter 1 out by today. If it's not, know that I'm waiting for my teacher to answer me which questions are with us and which are not. And be careful for tomorrow, because Tara is going to be posting your notes. He's going to be posting quick reviews, last minute guidelines and what you should do. I think he's going to be posting some extra questions that he got, or like extra questions from him. And yeah, that's it for now. Bye.